Hello everyone, this is Amika Mahajan. Welcome to my channel. This video is focused on important questions of 1 mark each from optics of class 12. First question, why must both the objective and eyepiece of a compound microscope have short focal lengths? Magnification depends upon focal length, inversely proportional to focal length of objective and focal length of eyepiece. Lesser the focal length, more will be magnification. So to have more magnification, the focal lengths are shorter in case of compound microscope. Focal lengths of objective as well as eyepiece are shorter. Next, when light undergoes refraction, what happens to its frequency? We know that frequency is the fundamental property of wave. So when light undergoes refraction, there is no change in frequency, it remains same. Next question, how does the frequency of beam of ultraviolet light change when it goes from air to glass? Again, it is undergoing refraction. And frequency is fundamental property, so frequency will not change when a beam of ultraviolet light goes from air to glass. What is the ratio of velocities of light of wavelength 4000 angstrom and 8000 angstrom in vacuum? All colors, they travel with same speed in air or vacuum. So different wavelengths have same speed in air and vacuum, as a result of which speed for 4000 angstrom wavelength light and 8000 angstrom wavelength light is same. So their ratio will be 1. In which direction relative to normal does a ray of light bend when it enters obliquely in a medium in which its speed is reduced? That means it is entering from rarer to denser medium. When it travels from rarer to denser medium, it bends towards the normal. Because denser the medium, lesser is the speed. So speed reduced means light is entering into denser medium from rarer, as a result of which it bends towards normal. How does the power of convex lens vary if the incident red light is replaced by violet light? Power is given by n-1 into 1 by r1 minus 1 by r2. N is the refractive index. And wavelength for violet color is less than as compared to the red light. So this wavelength is also related to refractive index n by Cauchy relation a plus b by lambda square plus c by lambda 4 and so on. So what happens? If wavelength is less, more will be refractive index. So violet color has less wavelength as compared to red. So refractive index of violet color will be more as compared to red color. So as a result of which, more power of convex lens will be there. Hence, what we find? Lesser wavelength, more refractive index, and more power. That means power in violet light will be more than power of lens in red light. And so if incident red light is replaced by violet light, then convex lens will have more power, as a result of which we can say power increases. A glass lens of refractive index 1.5 is placed in a trough of liquid. What must be the refractive index of the liquid in order to make the lens disappear? Lens will disappear only if its refractive index matches with the medium in which it is placed. That means this liquid should have same refractive index as that of the lens. So it should be 1.5. When light undergoes refraction at the surface of separation of two media, what happens to its wavelength? We know that as light undergoes refraction, speed changes, as a result of which wavelength changes. Because frequency is the fundamental quantity, it remains same. And speed is given by wavelength into frequency. If speed changes on change of medium, then because frequency is constant, wavelength must change. That means wavelength changes when light undergoes refraction at the surface of separation of two media. What type of wavelength wavefront will emerge from a point source? Point source has light rays in all directions. If we draw wavefront, it will be spherical in nature in case of point source. And distant light source, it will be plane. Distant light source means rays are coming in parallel form from infinity. So the wavefront will be planar in nature. So wavefront will emerge from distant light source as plane wavefront. When light travels from a rarer to denser medium, speed decreases. Does this decrease in speed imply a decrease in energy carried by the light wave? Justify your answer. No, decrease in speed does not mean that energy carried by light wave decreases, because energy is directly proportional to square of amplitude of the wave and it is independent of the speed. So there is no change in this energy on change of speed. Thanks for watching this video. Like, share, subscribe my channel.